I guess most of the people would have gone through machine learning projects at least once. And while working on those projects, we all should have done data cleaning and prepared it for model training by splitting the data sets into training and testing data sets, right? And even after training our model, we sometimes can't predict new data that we give to the model. And that is the basic problem of overfitting. So in this video, we are going to see how to tackle overfitting problem you face while training your model. Hello and welcome to this video on cross-validation in machine learning by Intellipaat. In this video, we will understand what is cross-validation, what are the different types of cross-validation methods, and at last we will also look into the demo implementation of cross-validation. But before we begin, please make sure to subscribe to Intellipaat YouTube channel and hit that bell icon to receive more updates like this.
Okay guys, now before we jump on to our main agenda point, that is what is cross-validation, let us first try to understand why do we need cross-validation. So imagine that you are training a model to recognize different fruits based on their pictures. You show it hundreds of images of apples, oranges and bananas, and it seems like it learning it all very perfectly. It also identifies every new fruit that you show to it. But wait, when you take the same model to a fruit shop and keep it in front of a fruit stand, then here it starts identifying all fruits as apples. So what went wrong here? So this is basically a class case of overfitting, where your model memorized the training data so well that it can't generalize to any new instances given to that. So as said, overfitting basically occurs when a machine learning model becomes too focused on the details that were given in the training data, remembering them too well but failing to learn any general patterns that would work on new examples. And this is where cross-validation comes in. Now let's jump on to our main agenda point. What is cross-validation? So as I said, cross-validation is basically a technique that helps us to overcome the overfitting problems by testing the model's performance on unseen data. And it also stimulates the real-world scenarios where the model will encounter any unfamiliar examples. Now let us move forward and see how this cross-validation actually works. So it starts with a raw data that was given to it, which then gets splitted into two sets, that is training set and testing set. So the training set is basically from where the model will learn, and the test set is to access the true ability of the model, like to see how this model is going to perform if it was provided with some unseen data. So once the data gets splitted into train and test sets, then in the next step we keep changing our test data sets and training model on remaining sets of data, and it keeps on iterating until we cover all folds as test data once. And once all that covered, then we come to our final step where we will finally calculate the average performance across all the key testing sets, which gives you a much more reliable estimate of how your model will perform on new data and not just the training set. So by stimulating several train and test scenarios, cross-validation basically gives you a more comprehensive picture of your model's generalization, which helps you to detect overfitting, adjust hyperparameters, and compare with other models. So if I say it in short, cross-validation is like building a bridge between your model's performance on familiar training data and its ability to navigate the real world of unseen example. So it helps you to avoid any pitfalls of overfitting and underfitting, which leads to robust models that truly understand what they were learned. Right? Now let's jump on to the types of cross-validation and try to understand it one by one. So there are four main types of cross-validation. First, validation set approach. Second, leave one out cross-validation. Third is k-fold cross-validation. And fourth one is stratified k-fold cross-validation. Now let's see all of these one by one and try to understand that. Starting with validation set approach. So in this method, we divide our input data set into training and test data sets, where both subsets are given 50% of the data sets. And then we perform training on the 50% of the given data set and rest 50, which is used for the training purpose. But here, the major drawback of this method is that we perform training on the 50% of the data set, and it may be possible that remaining 50% of the data contains some important information that we are leaving while training our model. So the second type is leave one out cross validation. So in this method, we divide the data into two sets, training and testing sets, but with a twist. So here, instead of dividing the whole data into two subsets, we are selecting a single observation or single data point as test data, and rest everything else is labeled as training data, and the model is trained on that. Now, on the second iteration, second observation or second data point is selected as test data, and the model is trained on the remaining data. And this process continues n times until we cover all single observations as test data once. And after that, the average of all of these iterations is calculated and estimated as the test set error. Okay, so when it comes to the test error estimates, this method gives unbiased estimates but an extremely high variance, because we are averaging the output of n models which are fitted on an almost identical set of observations, and their outputs are highly positively correlated with each other. And you can clearly see this is a computationally expensive, as the model will run n times to test every observation in the given data. And that is where our next type will tackle this problem and gives us a good balance between bias and variation. So our third type is k-fold cross-validation. So in this technique, the whole data is divided into k sets. And here, we will define the value of k for every data set. And from that, the first set is then selected as the test set, and the model is trained on the remaining k-1 sets. Then in the second iteration, the second set is selected as the test set, and the remaining k-1 sets are used to train the data, and the error is calculated. And this process also continues for all the k sets. And only after that, the mean of errors from all of the iterations is calculated as the cross-validation test error estimates. But the best part about this method is each data point gets to be in the test set exactly once and gets to be a part of training set k-1 times. So as the number of k-fold increases, the variance also decreases. Now coming to our fourth type, which is stratified k-fold cross-validation. So in this method, there is a slight variation from k-fold cross-validation, which uses stratified sampling instead of random sampling. So let's quickly understand what stratified sampling is and how is it different from random sampling. Suppose your data contains reviews of a cosmetic product used by both the male and female population. So when we perform a random sampling to split the data into train and test sets, there is a high possibility that most of the data representing males is not represented in the training data but might end up in the test data. When we train the model on sampling training data that is not a correct representation of actual population, the model will not predict the test data with good accuracy. So that is where stratified sampling comes to the rescue. Here the data is split in such a way that it represents all the class from the population. So let's consider this previous example, which has a cosmetic product review of 1,000 customers, out of which 60% is female and 40% is male. And then I want to split the data into train and test data in the proportion of 80:20, which means 80% of 1,000 customers will be 800, which will be chosen in such a way that there are 480 reviews associated with the female population. And after each iteration, we keep on changing our training sets like the same way that we have done in the k-fold cross-validation. We keep on changing our test data, and at last, we will take the average of that all test data, and from there, we will find the cross-validation test error estimate. And using that, we will calculate the cross-validation test error estimate. So this is exactly what stratified k-fold cross-validation does, and it will create k-folds by preserving the percentage of sample for each class. So this solves the problem of random samplings associated with hold-out and k-fold methods. Now let us see the benefits of cross-validation. So the first one is overcoming overfitting. So cross-validation helps us to prevent overfitting by providing a more robust estimate of the model's performance on unseen data. Second one is model selection. So cross-validation can be used to compare different models and select the one that performs best on the average. Coming to third one, which is hyperparameter tuning. So cross-validation can be used to optimize the hyperparameters of a model, such as the regularization parameter, by selecting the values which results best performance on the validation set. And the fourth is data efficiency. So cross-validation allows the use of all the available data for both training and validation set, which makes it a more data efficient method compared to any other traditional validation techniques. So that now we have seen what cross-validation is, how it works, and also what all types are there in cross-validation. Now let's see a demo implementation of it. Okay, now here I have opened a new collab notebook. So the first thing that we will do here is import all of our dependencies. So I will import the dataset first. For that, I will write here sklearn dot datasets, and I will import the iris dataset here. So I will write load iris, and then I need to import the k-fold method using which we are going to show you the implementation of this cross-validation. So for that, I will write here from sklearn dot model selection, and then I will import k-fold here. And with that, I have to also import cross-validation score to basically show the cross-validation score that we are getting after performing the cross-validation. So we have to import that also. And then I will import any machine learning model here. So here I am importing logistic regression. So for that, I will write sklearn dot linear model, and then I will import logistic regression. Right. So these are all the dependencies that we need for this demo implementation. So let's run that. Okay. Now I will load this iris dataset. I will write load underscore iris. So I'm loading this iris dataset inside this iris variable. Right. Then I will define here x and y. So I will write x equals to, I will provide it with iris data, and then for y, I will provide it with iris target. Right. Now let's run this. So now here we are going to perform the cross-validation using the k-fold cross-validation method. So we will write here k-fold, then we will provide it with the number of splits parameter. So this is nothing, but as I said, we have to provide the value of k whenever we are using k-fold cross-validation method. So we are basically providing that value here. So I'm writing n splits equal to 5. So we are basically providing the value of k as 5. Then we will write here shuffled equals to true. And then we have to pass a random state here. So I will write 42. So now let's run this. Okay, there is an error. This shuffle. Now let's run it again. Okay, now as this part executed successfully, now we will initiate our machine learning model here. So as you know, I have imported logistic regression here. So I will initiate that machine learning model in this model variable. So I will write here logistic regression, right, that I'm using for this implementation part. So let me run that. Okay, so now as we have performed our cross-validation, we have also initiated our machine learning model. So now let's print our cross-validation scores. So we will write here scores equal to, I will pass cross-validation score here, and then the model name X, Y, and then our cross-validation. So our cross-validation here is k-fold, which we have stored in a variable kf, right? And after that, I will write here print, and then cross validation scores, and then I will pass here scores, and after that I will print mean accuracy. So for that I will write here scores dot mean, right? So now let's run this and see what we are getting as our cross-validation score for this iris data set, which we are doing using the logistic regression model. So now let's run that. So as you can see here, for our 5 folds, we got the 5 cross-validation score. The first one is 1, second one is also we are getting 1, third one we are getting is 0.93 something, and fourth one we are getting 0.966, and fifth one we are getting 0.966. And after taking the average of all of these accuracies, we are getting our mean accuracy as 97.33, right? So this is the mean accuracy that we are getting using the k-fold cross-validation method, right? So that's how you can also use other method also, like validation set or leave out ones method, like validation set, or you can use leave one out method also in the place of k-fold cross-validation. So that's all we have for this video. I hope you got a good understanding about what is cross-validation, how it works, and also how to implement it using Python and scikit-learn library. Thanks for staying with us till the end. If you found this video helpful, please give it a thumbs up and share it with your fellow mates. And also make sure to subscribe to our Intellipaat YouTube channel so that you won't miss any updates coming from our side. Thank you so much.
Just a quick info guys, Intellipaat offers machine learning course in collaboration with IITM Pravartak. Through this course, you will learn various algorithms and machine learning techniques such as supervised, unsupervised learning, natural language processing, and much more from the IIT Madras faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given below in the description. Without a doubt, this course can set your career to new heights. So visit the course page given below in the description and take a first step towards career growth in the field of machine learning.